Alrighty, friends, we're going to talk about some more specific ways to count. Yesterday we talked about briefly sample space, which is like writing all the options out, and that fundamental counting principle. Today we're going to add in permutations and combinations. Permutations and combinations are specific situations that you can use kind of shortcuts. So before we do that, the formulas for each of these will require us to understand like a new math thing. So let's talk about that. Just to think back to yesterday, in how many ways, Cam, or can you put 5 photos on the wall? Well, if you have 1, 2, 3, 4, 5 photos to put on the wall, you have 5 choices for the first spot, then 4, then 3, then 2, and then 1. When you count down like that, and you have one less choice each time and you get all the way down to 1, that is called factorial. So that's a new math term, and it's written like n factorial. So this would be like however many items you have. And if you're using all of them, but once you use one, you can't use it again, so you keep going down by 1 each time, that's called n factorial. So like I would have n items, then n minus 1, then n minus 2, all the way down until I just have 1 left. So we want to be able to find that on our calculators. And so it depends on what you have. If you have a graphing calculator, you're going to go to the math key, and then you're going to go over to PRB, which is a menu across the top. It's the last menu, and then you will see as you drop down, I think it's like 4 or 5. Let me look at my calculator. Math, go over to PRB. It is number 4, and it's just an exclamation point, and then it knows what you can do. So if you go to your calculator and you do 5, if you don't have a graphing calculator, you got to find PRB, probability, somewhere on your calculator, and then it'll be in that list of options. Help each other figure out where that is. But if I go to math probability, and I'm going to do this, I'm going to have to type my 5 first and then get my factorial, and it will do 5 times 4 times 3 times 2 times 1, and I get 120 ways that I could arrange those pictures. So 10 factorial is going to go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. But I don't want to have to do all that out, so I'm going to go ahead and do 10 factorial, and that is this big fat number. And I don't care what the number is, I just care that you're able to figure out how to get that on your calculator, so figure that out. Now, something like this you can do on your calculator, but also use a little bit of logic. 6 would be 6, 5, 4, 3, 2, 1. Keep that in mind. And 2 factorial would be 2 and 1. So these would actually cancel, and your answer is going to be the same as 6 times 5 times 4 times 3, and that's 360. Or if I went to my calculator and did 6 factorial divided by 2 factorial, I'm going to get 360. So in that case, you could do either one, but if you try this next one on your calculator, 210 factorial, and then divided by 209 factorial, if you just do it on your calculator all the time, you're going to get an error because your calculator runs out of storage. It doesn't know enough to like think through it. It just does 210 times 209 times 208 and so on. So think about what this means. This means 210 times 209 times 208 all the way down to 1. But this one is 209 times 208 all the way down to 1. So what happens is these would cancel all the way down, and my answer is just 210. So if that happens to you, make sure you don't just write error overload, because it doesn't mean you can't do it. It means your calculator can't do it, and you have to look at the numbers and understand the concept of factorial enough to figure out that that would just be 210. Okay, so we're going to use that in these permutations and combinations. In permutations, what I always like to say is that it's a specific arrangement. So it's not just a general group. It's a placement of items, like crossing the finish line first, second, third. You know, that's like the order of that is is important. And then a specific situation might be like a seating chart. So I don't just know who's in my class, I'm actually going to place them into certain chairs. It might mean a coach that's selecting a batting order or is assigning positions on a team. So I always think that a permutation is placement. It's placing things specifically. And then the formula for that, however many items you have, I don't know why there's not a spot for the formula here. It's kind of annoying. So if you have n items and you're going to place r of them, so this is how many you have, this is how many you're going to actually place, you're going to go ahead and have a formula where it's n factorial, so that's why we studied that. Then you take n minus r and do that factorial, and you're done. Sorry, I made that weird and want to move that over. Okay, so that is going to be our formula, or we're going to be able to find this on our calculators and use that for when it's a permutation. Now, the other option is combination. And a combination I think of as a general group. So here, I'm not putting you in a specific position or seating you. I just have a general group. And so maybe this is just going to be like my class list. That's just the group of kids who are in my first hour. Or maybe this is just going to be like choosing the team. Like who makes varsity, and then after that I can make more decisions about who's playing what position. But for right now, I'm just choosing people. Or if I need like 3 helpers, well, I'm just picking 3 kids. So same situation, except here I'm just going to be like choosing a group, not placing them specifically. So I might be like, hey, who's going to be on the prom committee? I need 10 of the 30 people who applied. So I'm going to choose 10 of those 30. I'm not assigning them specific roles. I'm just choosing a group of kids to help. So NCR is going to be how many items I have. And then R is the number of items that I'm actually going to choose. And the formula for that is really similar in that it's n factorial over n minus r factorial, but you have another r factorial. And you got to make sure that you're dividing by that entire bottom. So that is the formula and the notation. But again, you can also find this on your calculator, hopefully. So let's figure this out. 5 people are racing. How many ways can first and second place be awarded? Since that's a specific placement, that is going to be a permutation. And so here in my chart, that's a permutation. So I have 5 people and I'm placing them in first and second. So that's going to be a 5 place 2. So using this formula, I'd have 5 factorial over 5 minus 2 factorial. So I'd have this over this, and then I can go to my calculator and you can do this a couple ways. You can say, oh, that's 5, 4, 3, 2, 1, and this is 3, 2, 1, so I expect to get 20. Or you can do 5 factorial, and 5, keep in mind math, and then down to this exclamation point, and then divided by 3 factorial, however you find that on your calculator. You're still going to get 20. And if you can find a place to do this on your calculator, that'd be great. On the calculator, on the graphing calculator, again, you go to the math key, go over to PRB, and you're going to see if you put the 5 in, and then you go math, PRB, the second one down is NPR, and then you would choose that and then put the 2. So on my calculator, it looks like 5 NPR2. And if you have a newer calculator, it's actually going to put the 5 there and put the 2 there. If you don't have a graphing calculator, you got to look around on there and find that probability menu. but make sure that you're choosing permutation if that's what you're doing. How about this? 4 people from a list of 10 are chosen to complete a project. How many different ways can you make groups? Okay, well, that's general. I just need 4 people out of the 10. So where this was 5P2, this is 10, and I'm choosing 4 to be in a group. So it's more general. So using my formula from up here, I'd have 10 factorial over 10 minus 4 factorial, and then r factorial, which is this guy. And I'm putting parentheses so my calculator knows to include that whole bottom. Or if you have that feature on your calculator where you can just do 10C4, that is definitely easier. It'll do that work for you. So I type in the 10, I go get that NCR, and then I put my 4. So this on my calculator, which is a little older, looks like a 10, then NCR, and then the 4. And you should find a way to get to 10. You can get it from the formula, or if you can find that shortcut on your calculator, that'll help you a ton. You're ordering t-shirts to sell in your store. There are 12 different colors the shirts come in. How many ways can you stock 5 colors? Okay, well, you're not putting them on hangers in a certain order. You're just saying I have 12 colors. I'm going to choose 5 of them. So I'm choosing 5 of the 12 colors. The formula would look like that. 12 minus 5 is 7, and then the 5 goes here. Or I can just do 12C5 on my calculator and say if I have 12 colors and I'm only choosing 5, how many ways can I do that? So 12, choose 5, it's telling me 792. And again, you have to find a way to get that on your calculator so that you feel confident. So there's 2 issues. 1, deciding if it's a permutation or combination, and then 2, figuring out how to get it in your calculator. Student council needs to vote 3 of their 15 members to be president, vice president, secretary. Okay, so I'm specifically placing them into those jobs. So of the 15 people, I'm placing 3 of them. That's a permutation. So in my permutation formula, I'll have the 15 over the 15 minus 3. That's it. Or I can do 15 place 3. And so I can do whatever way makes the most sense on my calculator, and I have to make sure I'm choosing a permutation if I'm doing my calculator. And there's 2,730 different ways I could choose my vice president, president, and secretary from 15 people. Okay, so distinguishable permutations means they actually look different. Like if I got 5 t-shirts that are all the same and I arrange them differently, it will not look different. So it's not considered a different arrangement because it looks the same. So how many ways can you arrange the letters in the word fuchsia? What you have to do when you have those repeats is you take, I always write with a highlighter. You take the number of things you have, factorial, but then for each thing that repeats, you divide out how many times it repeats, factorial. So that's kind of confusing. Let me show that to you in action. Here I have 1, 2, 3, 4, 5, 6, 7 different letters that I could arrange. None of them are repeats. So 7 factorial is my answer. Like I would have 7 options, then 6, 5, 4, 3, 2, 1. So that one is pretty straightforward. I would have 5,040 ways to rearrange those letters. Now, Mississippi is going to be a different deal because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But moving the S's to where the other S's are is not going to look different. So that's one thing that repeats are my 1, 2, 3, 4 S's. So I put that because those are repeats and will not look different. So that's representing the repeating S's. The 2 P's, I do 2 factorial for that because those, if I move them into each other's spots, won't look different. And then last, you can see I have 1, 2, 3, 4 I's. And if I move those into each other's spots, they won't look different. So I'm dividing out all the options that actually do not look different. So I type in 11 factorial, I divide by, and then in parentheses, I do exactly what it says, 4 factorial. times, and then I put 2 factorial, and then I do 4 factorial again because of the other letter. And it's giving me 34,650 ways, because 11 factorial would be a lot of ways, but a bunch of them would look the same because I'd be moving one S to where the other S was, and it wouldn't count as a different arrangement. So that's something to watch out for if you have things that are identical or they look exactly the same. You got to divide that out. So hopefully that helps, because tomorrow we're going to start probability, and that requires us to count up all the ways stuff can happen. So that's what we've been learning. Bye, guys.